In Figure 8.2, you'll see some what we call scanning electron microscope images of clay. So these first three, A, B, and C, are clay. You can see that A is a kaolinite. That's a form of clay. And the thing to notice is that it's a mineral. This is going to be important when we think about what the structure of this mineral is later that gives rise to the charge on a clay soil. So the first thing to note is just this mineral-like structure of the kaolinite that we see in figure in A. The other thing to notice is that you can see all these plate-like the plate-like mineral nature of clay, and we've thought about how clay is very, very small but can hold a lot of water, or very, very small and has a lot of surface area. And the reason is because it's much like a book. So if this were the binding of the book here, and here were the covers, you could see that if we measured the area, the surface area of each page, we would have a lot of surface area in just this small space. So that's one thing to notice there. Another one here, C, since we are teaching out of Wyoming, is that we have a montmorillonite here, an expanding clay, a swelling clay. We'll see later that that clay is an important clay because it does that. We've seen that with vertisols. Vertisols have a high amount of this type of clay, that when water is present, it will expand, and when water is absent, it will contract. Finally, in D, we have fulvic acid, which is kind of a representation of what organic matter might look like, and so we have a representation of that. So just so you start to see when we're talking about these clays and this organic material, when you see that, when you see pictures like this, it gives your mind something to sort of think about while we're talking about the structures and the capabilities of these kinds of colloids in the soil.